Welcome to Brain Vision.
Okay, this is question 5104. We have a 4 kilogram block attached to a vertical rod, and there are 2 strings attaching the block to the rod. And this system is rotating around the axis of the rod. And we know that the tension in the upper string here is 80 newtons. So let's list that out here. The tension is 80 newtons in this upper string up here. So we'll call that TU to indicate upper. And in part A, we're asked what the tension is in the lower chord. So we can set up a free body diagram here. We know that there's going to be some acceleration, which is going to be directed to the left here. So let's denote x, the plus x direction, to be to the left to just make things easier here. We know that the tension in the upper string up here, that's up here, tension is 80 newtons. And there's going to be some tension, which we'll call TL, in the lower string, so that corresponds to here. Then we're going to have the force of gravity pulling down, so that's mg down here. So to solve this, we're going to want to use the fact that the sum of the forces is equal to mass times acceleration. And here the acceleration is going to be equal to v squared over r. So v is the velocity of this block, since this is centripetal acceleration because it's moving in a circle. So let's first figure out what r is. So r is going to be the radius of the circle that this block moves around. So it's going to be the distance from the rod. So I've put that here in red. So we can see that this makes a triangle where we have this whole thing is 2 meters. Oh, sorry. So this whole distance is 2 meters. So that means that the height of this triangle is 1 meter. And then the hypotenuse of this triangle is 1.25 meters. So we can set up using the fact that the cosine of an angle is equal to the adjacent side over the hypotenuse. So we can say cosine of theta here, where theta, again, we've indicated down here, is going to be equal to 1.00 meters. So that's the height here, divided by the hypotenuse here, which is 1.25 meters. So we can calculate this by just plugging in cosine theta is 1 over 1.25. And when we solve that, take the arc cosine of both sides, we're going to get that theta is equal to 36.9 degrees. So we now know that this angle here is 36.9 degrees. And now to find r, we just want to use the Pythagorean theorem because we know that we have our a squared, so 1.25 squared is going to be equal to r squared plus 1 meter squared. So this is using Pythagorean theorem here. When we rearrange, we're going to get r squared is equal to 1.25 squared plus 1, because 1 squared is just 1. And then we just want to take the square root of both sides to solve for r, which is going to give us r equals 0.75 meters. So we now have our angle, we now have r, and now we're ready to start plugging in to our equation up here. So let's first look at the forces in the y direction. So indicate here, this is going to be some of the forces in the y direction is going to be mass times the acceleration in the y direction. So we know that this block is staying at the same level in the vertical plane. So the acceleration in the y direction should be equal to 0. So this right-hand side of this equation is going to be m times 0, which is just 0. So when we plug this in, we are going to have, we have 3 vertical forces here. So we have the tension pulling up, so that's TU u times cosine theta, indicated right up here. And then we're going to have, pulling down, we have t lower, also times cosine theta. So that's this force down here. And then we have our force of gravity. So that's going to be m times g. And that's all equal to 0. So we know what TU is. TU is 80. We don't know TL, but we know theta. Remember, we found cosine of theta is 1 over 1.25 up here. So we know cosine theta already. And we know that the mass is 4 kilograms and G is 9.8. So we can just plug all of these in and solve. So first, let's just rearrange this equation for TL. So to do that, first we're going to want to move that over to the left side. We're going to end up with this term is going to go over here. This will become positive. So now solving for TL, we just need to divide by cosine theta. So when we divide this first term by cosine theta, that'll just cancel out. And then we divide the second term by cosine theta, we'll just end up with this. So we know TU, we know M and G, and we know cosine theta. So when we plug everything in here, we should just get TL is equal to 31.0 newtons. So notice we didn't even have to use anything in the x direction to solve this. The y equation was good enough to answer the question in part A. So now part B asks, how many revolutions per minute does the system make? So here, this is where we're going to have to use the equation in the x direction. So this was all for part A, but let's now do the same thing for part B. But now, instead of looking at the y direction, we'll look at the x direction. So I'll just indicate that here. So fx is going to be m times a in the x direction. And since we know that the acceleration is purely in the x direction, I'll just leave this as a here. Remember, our a is v squared over r. So I'm just going to plug that in right now to make it easy. So the sum of the forces is going to be equal to mv squared over r. So let's follow the same steps as we did before. So looking at this force diagram here, we see that there are two forces, one from the tension in the upper wire, that's Tu sine of theta, and then the tension from the lower string, which is going to be TL sine of theta. So we have our Tu, and then we have times sine of theta. And then since these are both in the same direction, we'll just add them. So TL times sine of theta. And again, that's going to be equal to mv squared over r. So let's take a look at what we know and what we don't know. Well, we just found TL. We found that TL is 31 newtons, and we were told that TU is 80 newtons. We found that theta is equal to 36.9 degrees. We know m is equal to 4, and we know that r, we found this before, is 0.75 meters. So the only thing that we don't know is v, and that's what we're looking for. We want to find the number of revolutions per minute. So we'll, v is going to give us the velocity. So we'll deal with that, converting this to revolutions per minute in a second. But let's just rearrange this so that we have this explicitly written out here. So we want to solve for v squared. So that means we're going to need to multiply both sides by r here. And then we're going to need to divide both sides by m. And that's how we're going to end up with v squared on its own on this in the left side. So remember, let's see, to solve for the actual velocity, all we're going to need to do is take the square root of both sides. So I'll just try to drop that here. Square root of all of this. And this is all, these are all terms that we know. So we can just go ahead and plug in R, TU, theta, TL, and M. And when we get that, we should get that V is equal to 3.53 meters per second. So this is just a regular velocity. So now we need to find the number of revolutions per second. So the number of revolutions per second is just going to be the velocity divided by the circumference of the circle. So the circumference of the circle that it's making, so going around in this circle, is just going to be equal to 2 pi r, where we have pi, and then r is the radius of the circle, which we found 0.75. So we just need to plug in 3.53 divided by 2 times pi times 0.75, and that should give us 44.9 revolutions. Oh, sorry. This is in revolutions per second, so we're going to get 0.749 revolutions per second. Now, the question asks us for revolutions per minute. So if it goes this many revolutions per second, then we just need to multiply it by 60, since there are 60 seconds in a minute, to get 44.9 revolutions per minute. This is going to be the answer to part B. Now, part C asks us to find the number of revolutions per minute at which the lower chord just goes slack. So if the lower chord is slack, then TL is equal to 0. So if TL equals to 0, then think about our sum of the forces in the y direction here. So this equation down here where we looked at originally. If TL equals 0, then we just have essentially this term, except without this. This is just 0 here, which means that TU would just be equal to mg times cosine of theta. So if we set this equal, we again, we're going to want to figure out what this tension is that would cause this equation to be satisfied. So if we plug in, we have m is 4, g is 9.8, and we know that our cosine theta was 1 over 1.25. So I'll just leave that down here. When we plug that in, we find that TU would have to be equal to 49.0 newtons. And now, let's take a look at our equation in the x direction. So we would have this equation, except again, TL is equal to 0. So we can just get rid of that again. We now have TU is 49. So we can plug this in. We again know that m is equal to 4. We know that our r is equal to 0.75, and our theta is 36.9. So we could just explicitly plug that in if we want. 36.9. I guess I could do that here too. We can plug everything in here and then again solve for v. So multiply both sides by 0.75. And when we do that, we get v is equal to 2.35 meters per second. And then again, we're just going to follow the same process as before to convert to revolutions per minute. So we again are just going to want to divide by 2 times pi times r. So let me just move this up here. So v over 2 pi r. And then we're going to end up, we want to multiply that all by 60. So I won't show explicitly this calculation, but we just plug this in and we should get 29 0.9 revolutions per minute. Now, part D says what happens if the number of revolutions per minute is less than in part C. So if we have even less, if this block is moving even slower than 29.9. So remember, this was the point at which there's just no tension in this bottom wire here. In that case, we're just going to have, it's as if this bottom wire was just not here at all. So we would have essentially just this block swinging freely only on this, only supported by the top wire here.